Welcome back to another CAD/CAM tutorial. In this tutorial, we are going to create a G-clamp using Siemens NX. So this is the part 1 of the Siemens NX G-clamp tutorial, where we are going to first create the individual components, which are the clamp, the lead screw, the bush, the bar, and the cap. And they have these drawings and dimensions. And in the next video that will come after this, we create the final assembly. So this is a very simple tutorial. Make sure you watch the video to the end so you know how to create the G-clamp using Siemens NX. And please like the video, subscribe, and turn on post notification to receive an alert anytime I upload a video. And make sure you share the video to your friends as well so they can also watch this Siemens NX G-clamp tutorial. Now let's begin. The first thing I'm going to do is to create a folder that will store all the files you create. So create a folder in the desktop, and I'll call the folder G-clamp assembly. This folder will store every file that we create. And then we open the Siemens NX software. Inside the Siemens NX window, create a new file. The workbench model, because we are modeling a part, the units should be in millimeters. The name for the part, this is the first component, the clamp. And then a folder to save it. You save it in the desktop in the G-clamp assembly folder. Click OK, and it will take you to the Siemens NX 3D modeling workspace. So we can now start. Now we are going to sketch the profile of this view, and then we use the dimensions on this front view here to extrude or to add material. So create a sketch on the right plane. With the profile tool, sketch the profile of the right plane. I'll make this line vertical and we start dimensioning. The full length here is 120 and the length here is 70 millimeters. So rapid dimension, this is 120, this length is 70 millimeters. This height here is 68 and this is 30 millimeters. So I'll click on this point and then hold the mouse and drag it here. Again, click on this point, hold the mouse and drag it here. This height here is 75 plus 23. And that will be 98, which will be the same as 68 plus 30. So just make sure that this line and this line are collinear. So click on the two lines. Make them collinear. And then again, you make sure the center points of these two lines, which is the 70 millimeters distance and the 120 millimeters distance, are all on the same vertical line. So click on this point and this midpoint, vertical alignment. Again, with the profile tool, we can now add this profile. Now make this line horizontal, which we can see here. This height is 23, this is 5, and the length or the thickness here is also 5 millimeters. Then there will be the last vertical distance that we have to add. But you see, the distance from this line to this line is the same from this line here to this and this to this. So just make sure this dimension, as we can see, is 20 millimeters. No need to dimension it. We give that same dimension to the bottom here for it to be 20 millimeters. And you can see the sketch is fully constrained. So click on finish sketch. Now extrude to add material. The thin feature in between, which is this space here, is 10 millimeters, and this is 20 millimeters. We are going to make it symmetric as well. So make sure you select region boundary curves, and then first click on this area. Symmetric value of 10 divided by 2. So we need half of the distance, so there can be half of one side and half on the other side. Apply. Again, region boundary curves, select this region, a symmetric value of 20 divided by 2. Boolean unite. Okay. Next, we rounding this face. It has a radius of 10 millimeters, so edge blend, radius of 10. Click on this edge and this edge. Okay. Then we add a hole of diameter 12 millimeters. So hole feature, a simple hole of diameter 12, sketch section on this face. Now with the sketch point tool, place the point on the center of this arc. Set the depth limit until next. Okay. Now we're rounding these corners as well. So this has a radius of 30, this 10, and then this 5. Again, edge blend, first 30. Click on this edge and this edge. Okay, not this edge, so come here to the deselect all, and then reselect again this edge and this edge. Apply, then 10 millimeters this edge, and then add these ones here. Apply, and then 5 millimeters here and here. Okay. Then we add the thread. It has a pitch of 2 millimeters. So locate the thread feature, a detail thread. Click on this area. The major diameter 14, the minor diameter 12. So the difference between the major diameter and the minor diameter is 2 millimeters. The length should be the distance from this to this, which we can see, since we saw earlier that the distance from this line to this line is 20 and this thickness is 5, so the length should as well be 25 millimeters. The pitch 2 millimeters, everything so okay. Now we control what we see, so show and hide all types, and then we show only the solid body. Okay, so the color is medium C. Come to edit object display, click on this object, and then we change the color to medium C. So this is the first part, the clamp. So save the part again, and then you move on to the second part. So create a new file. The second part is the lead screw. Okay. The lead screw is a round figure, so we are going to use a revolve. So revolve, sketch section on the right plane. Okay. So the profile tool, sketch half profile of the lead screw. I'll make this line horizontal, and now we can start dimensioning. The diameter of this is 6, this is 12, and this is 20 millimeters. But since we sketched half, we need just half of the dimension, so 6 divided by 2. This will be 12 divided by 2. And this will be 20 divided by 2. As for the horizontal distances, we need the full distances. No need to halve them. So this is 22, this is 12, and the full length is 130. Sketch is fully constrained, so finish. The axis of revolution, click on this horizontal line. Okay. And then you create a hole here of diameter 6 at a distance of 12 from this line. So extrude, sketch section, sketch on the right plane. Okay. A circle of diameter 6. You make sure the circle is in the middle of the shaft. So we just click on the center of the circle and click on this x-axis, point on curve. The distance from this center to this line is 12. Finish. Now symmetric value, and then just click on this arrow and pull it outside. As you can see here, set the boolean to subtract. Okay, so this is the hole created. Then we add the shaft. The thread pitch is 2 millimeters. The thread starts on this face, and the distance of the thread is 90 millimeters. So locate the thread feature, detail thread, click on the shaft. As you can see, the thread starts from here to this face. Or you can just select start, click on this face, reverse the thread axis to come in this direction. The major diameter is 11.99, so the minor diameter should be 11.999999 minus 2 exactly, because we saw that the difference between the major diameter and the minor diameter of the thread in the clamp is 2 millimeters, and the length is 90 millimeters. The pitch is 2 millimeters. Okay. Now we control what we can see. So again, view, hide or show. Hide all elements and then show only the selected bodies or the solid bodies. Edit object display, and then the color is smoke gray. Okay, so again, save the parts. and then we move on to the next part. Next part is the bush, which is also a round figure, so we are going to use the revolve as well. So again, revolve, sketch section on the right plane. Okay, so we are going to sketch half of the profile and then revolve around the horizontal axis. So with the profile tool, sketch half of this profile. Now let's constrain it. So click on this point, and then the vertical axis, point on curve. The distance from this point to this is 14, and this is 7 millimeters. So since you sketched half from this point to the 7 divided by 2, from this point to this vertical axis is 14 divided by 2. And then this diameter is 20. So from this point here to the vertical axis is 20 divided by 2. This length is 3 and this is 16. Now this is 11 millimeters and the length here is 2. So from this point to the x-axis is 11 divided by 2, and this length here is 2 millimeters. So you can see the sketch is fully constrained. So finish. Axis of revolution, click on this horizontal line. So this is not quite the shape that we want. So the axis of revolution, deselect all, and then you're going to use this y-axis here. Okay, so this is actually what we want. The color should be medium gray. So hide or show, hide all elements and show the solid bodies. Edit object display, change the color to medium gray, and then save the part. Move on to the next part, which is the bar. The bar is just a long cylinder of diameter 5 and then a length of 96 millimeters. So we are going to use the extrude sketch section on this front plane. Draw a circle of diameter 5 millimeters. Finish. And then the length, we make it symmetric. We need half the value, so 96 divided by 2. Okay. Then we change the color to smoke gray. And save the part. Move on to the last part. This will be the cap. So we still use the revolve feature for the cap. Revolve on the right plane. So we are going to sketch half of the profile. Now click on this point and the y-axis, point on curve. This point and the x-axis, point on curve. Now let's dimension. This diameter is 8, this is 5. So 8 divided by 2. And this will be 5 divided by 2. The full length is 9 and this length is 6 millimeters. Sketch is fully constrained to finish. And then the axis of revolution, we use the y-axis. The points will be the origin, so come to this and make sure the references are all 0. Okay. And then we have a chamfer of 0.5 millimeters. So chamfer, a symmetric chamfer of 0.5 distance, and click on this edge. Okay. Show only the solid bodies. And then we change the color to medium gray. And save the part. So for the lead screw, you have to add a chamfer here of distance 2 millimeters. So chamfer of 2 millimeters, symmetric. Okay. Again, save it. And these are all the parts that we need to create a G-clamp. So that is the end of this tutorial. In the next video, we're going to create the final assembly.